In this video, we're working problem 3.1.10 from the Essentials of Statistics text by Mario Triola, 6th edition. We're asked to find the mean, median, mode, and mid-range for a given sample of data. And then they tell us a little bit about the sample. So the problem statement says, an experiment was conducted to determine whether a deficiency of carbon dioxide in the soil affects the phenotype of peas. Listed below are the phenotype codes where 1 equals smooth yellow, 2 equals smooth green, 3 equals wrinkled yellow, and 4 equals wrinkled green. And then we're asked if this results make sense. And then we're given this set of data right here. What I've decided to do for this video is I'm going to work all of this out on paper, and then I'm going to show you how to do the exact same thing in Excel much faster. So first I will show you how to calculate the mean on paper. In A, it asks us for the mean phenotype code, and it asks us to round to the nearest tenth as needed. So I'm keeping that in mind. I'm going to stop sharing this and then share my document camera with you. Here we go. Okay, so we've got our problem statement. And we're asked for the mean phenotype code. So we're just going to add all of those together and divide by the total number of values. Actually, there was an S missing there. Okay. So when you're calculating the mean, you just add the numbers together. So you're going to have 2 plus 1 plus 1 plus 3 plus 1 plus 2 4 times, plus 3 plus 2 plus 3 plus 4 plus 1. And you're dividing by the total number of numbers on that list. So I've got 5 here, so that's 9. Actually, I can just look at this as 10 and 4, so that's 14. I'm just going to add those together and divide by 14. Of course, you could do the arithmetic in your head, but I'm going to use a calculator. So we've got 2 plus 1 plus 1 plus 3 plus 1 plus 1 plus 2 plus 2 plus 2 plus 2, there are 4 2's, plus 3 plus 2 plus 3 plus 4 plus 1. And you want to take that 30 and divide by 14. And then they want us to round to the nearest tenth. So that is approximately 2.1. So that is the mean phenotype code. It's 2.1. So now I will switch to sharing my screen with you again. Oops, that's not the screen I want. Sorry about that. Try one more time. There we are. The mean phenotype code is 2.1. Let's see if MyLab Statistics likes it. Yes, we got some good feedback. All right. And now we want the median phenotype code. In order to find the median, remember you have to put all of the numbers in order, and then you're looking for that middle number. So I will start sharing my paper with you again. In order to do that, we have to put these numbers in order from smallest to largest. So I've got 1, 1, 1, 1. I've got 4 ones. Then I've got 1, 2, 3, 4, 5, 6 twos. And then I've got 1, 2, 3 threes. And a 4. So we put them in order. And then we cross them out 2 at a time. So get rid of those 2. And get rid of those 2. And get rid of those 2. Oops, and get rid of those two. Then I think we get rid of those two, and I think we can see that since we had an even number of numbers, the middle two numbers were 2 and 2. Then you take the mean of these. So you take them, you add them together and divide by 2, but since they are exactly the same, adding them together and dividing by 2 just gives you that number back, which is a 2. So our median phenotype code is a 2. So I'll go back to sharing my screen. Oops. Okay, it likes that as well. And now we want the mode for the phenotype code. Now remember what the mode is. That is the value that appears with the highest frequency. We had 4 1s, 6 2s, 3 3s, and a 4. So the value that appears with the highest frequency is 2. So that's our mode. Whoops, I wrote writing some hybrid between the and mode for some reason. The mode is 2 because it appears with a frequency of 6 actually, or 6 2s. Okay, let's see if my lab statistics likes that. Oh, I typed 6 because there were 6 of them, but I meant 2. 2 appeared 6 times. So the mode is 2, not 6. All right. Oh, I don't know why I accidentally put there is no mode. Final check. Here we go. Wow. Okay, it's getting late and I'm tired. So yeah, that is the mode phenotype code is 2 because the 2 appears 6 times. And then the last thing we're asked to do is find the mid-range of the phenotype codes. And remember how you find the mid-range. Mid-range is found this way. You take the max and the min, maximum value and minimum value for your data set, and then you add them together and divide by 2, like you're taking the mean of the maximum and the minimum. So the maximum value on our list of phenotype codes is 4. The minimum value is 1. So we do 4 plus 1, divide by 2, so 5 over 2, or 2.5. Okay. Back to the homework. And it says type an integer or a decimal, so it didn't want that fraction 5 over 2, it wanted 2.5. That's good to know. Make sure you focus on, or make sure you read that fine print, that print that's in blue below the problem statement. Okay, now it's going to ask us some problems about this data set. The first question it asks us is this. It says, do the measures of center make sense? And it says only the mode makes sense since the data is nominal. Only the mean, median, and mode make sense since the data is numerical. All measures of center make sense since the data is numerical. Or only the mean, median, and mid-range make sense since the data is nominal. Now remember, nominal data is data that is at that nominal level of measurement, which means it's categorical only. It can't even be ranked. Well, that's true when you're talking about phenotypes. Smooth yellow, smooth green, wrinkled yellow, and wrinkled green. They can't even be ranked. So this is definitely nominal data, and it really doesn't make sense to compute a mean, median, and mode with these numbers that are standing in for names. So the only measure of center that makes sense with nominal data is mode. So that's the category that appears the most often. So only the mode really makes sense. And that's it.